All right, people at home, you are in live learning time with us. I'm talking to you about something that the kids in this room have not seen yet, all right? If you're doing your homework at home, this is the second little video I want you to watch, okay? And I'll try to make it short. So here we go. Remember the formula. Now remember, we were just talking about weighing things and determining how many moles were there. You just did a worksheet on that, okay? That worksheet's labeled number 2. Well, the next worksheet we're going to work on will be labeled number 3 for you, okay? So if you'll remember, there was a very important formula that I showed you, and it starts out like this. The number given over 1 times 1 over the proper number equals the number of moles that you have, okay? So anytime you've gone through 2 steps of a problem, you have the number of moles. Now, let's look at this. What I want you to understand is that these 2 numbers always have to be the same units, okay? In the last worksheet that we did at the beginning of class today up till now, we were given a number of grams, and then we ended up dividing by the number of grams that a mole of it would weigh from the periodic table, the proper number. Does that make sense? Right? The proper number is the correct number for 1 entire mole. For example, if you had O2, oxygen gas, the proper number would be 32 grams of oxygen. That would be 1 mole. Does that make sense? Right? And the given number will be how many grams you have in your sample. So if you were given 8 grams of oxygen gas, 8 out of 32 would be 0.25 moles. All right? So now I'm going to talk to you not about grams, but about actual numbers of particles. Okay? Now, look up here at the top of the board. I'm shifting it up to right here for the kids at home. This is the number of atoms or compounds in 1 mole of a substance. Just like 12 is the number for a dozen, this is the number for a mole. 6.0 times 10 to the 23rd. It's a very large number. It's roughly equivalent to all the grains of sand on all the beaches and all the deserts in the world. It's a freaking big, big number, okay? Now, if you have this many atoms of a substance, you have an entire mole of it, right? So let's think about this. What if we were doing this problem about donuts? And I said, hey, you only have 6 donuts. That's the number of donuts you're given. What's the proper number for a dozen donuts? 12. So you would have not half a mole, but half a dozen donuts, right? So these problems are really just like that. We're not talking about how much things weigh. We're talking about how many particles you have. All right? So the number given times 1 over the proper number. Here's what I'm going to tell you. What if you were given 1.5 times 10 to the 23rd atoms of sodium? Then you'd be like, okay, I'm given 1.5 times 10 to the 23rd atoms of sodium. How many atoms of sodium? What's the proper number for the number of atoms of sodium that are in a mole? This. It's not 23 grams. We're not talking about how much the sodium weighs. We're talking about the proper number for 1 mole of sodium. So that will be 6.02 times 10 to the 23rd. So 1.5 times 10 to the 23rd times 1 over 6.02 times 10 to the 23rd. That'll give us, obviously, 0.25 moles. Now, I say obviously. You haven't done this before, but let's do it with our calculator. If you're at home, please listen carefully. Okay? We're using these rectangular calculators. I'm going to say the expression EE. EE is a button on the calculator. That means times 10 to the. If you can download a calculator on Google that has this EE button on it, it will make your life easier, okay? If not, you need to understand scientific notation. So please follow along. I'm going to enter the number 1.5 times 10 to the 23rd. On this calculator, I hit 1.5 EE23. That's what everybody in class is doing. At home, with whatever calculator you have, you need to understand how to enter 1.5 times 10 to the 23rd. And there are so many different calculators, I can't possibly teach you the process, okay? You need to figure that out, all right? 1.5 times 10 to the 23rd times 1 over 6.02 times 10 to the 23rd. In other words, 1.5 times 10 to the 23rd divided by 6.02 EE23. That gives you 0.25. So if you have this many atoms of sodium, you only have 1/4 of a mole. That's how simple it is. This is the same problem that we've been doing, except for this time we're given a number of atoms and we use the proper number for the number of atoms. The last video we were given a number of grams and we used the proper number for a number of grams. Does that make sense? Let's try another one. What if I gave you a problem that said you have 2.4 times 10 to the 24th atoms of aluminum. How many moles of aluminum would you have? You would say 2.4 times 10 to the 24th times 1 over 6.02 times 10 to the 23rd. You would have right at 4 moles. We can try this on your calculator. Ready? 2.4 EE24 divided by 6.02 EE23. And that gives you 3.98. I did that in my head. I should have guessed at least 3.99, 3.98 moles. All right? So try to do this. Don't get frustrated. Let's try to do some of these problems from the second worksheet, okay? And I will post those online for you. Peace out.